Okay, so we're going to have a look at another question from the 2020 HSC Standard 2 paper. This is just a short question. This is 27B. So we're going to talk about 27B, separate from 27A. This says, should the answer to part A be more than, equal to, or less than the actual answer of the garden? So in 27A, we looked at this garden and we calculated an approximate area by turning this shape that sort of looks like this into two trapeziums that look like this. So we have one trapezium here, one trapezium that's actually a square over here. So we called this A1, we called this A2. We calculated this to be 850. So the total area we found was 850, and this was in, I believe, meters squared. So should the answer be more than, equal to, or less than the actual area? This is worth 2 marks. It's going to be more than. So the total area is going to be greater than the real area. The reason for this is we have two little bits in here, this curved bit here and this curved bit here. These are not in the real garden. Right? These are not in the real garden, but they are counted in the trapezoid rule estimation. And so in this case, the total area will be greater than the real area because there are bits that are not being counted. You should note that it's not always the case, and the reason I'm doing this as a separate part is it's not always the case that trapezoid rule will overestimate an area. It may underestimate an area. So as a side note to this question, don't always assume that trapezoid rule or Simpson's rule or whatever rule you're doing underestimates. Don't always assume it overestimates. It does one of those in some cases and one of them in another. So if we have two gardens, and we're going to draw them in these two rectangular boxes, we're going to see a case where it overestimates and then a case where it underestimates. So we might have something like starting over here, the garden curls up and goes to this point, and then it goes down and goes out to this point. So we have 3 points here. If we turn this into some trapezoids, we'll change color to red, we have one trapezium here, and we have one trapezium here. Now in this case, the total area of the trapezoid rule calculation will be greater than the real area, mostly because of this bit here. Right? There's a massive overestimation in one of the applications of the rule. If we started doing more applications of trapezoid rule, this error would start to disappear. So if we have a look at a similar shape over here, we might have something like this that curves up and then it curves down like this. If we used trapezoid rule here, so again we'll get our red out, here to here and down, here to here and down, this would underestimate. Here the trapezoid areas would be less than the real area of the garden. It would underestimate because now we're missing two bits that the trapezoid rule is not considering. If we then cut these up into more iterations of trapezoid rule, let's say 4 iterations, so we'd get this one here, we'd get the midpoint, one here, and then one here, and then we did it again for this shape as well. Get a trapezium here. These are just crude approximations to show you what's happening. If we cut it into 4 as opposed to 2, or 3 as opposed to 4, or something like that, you can see now that we have 4, this is much, much closer to the correct area. And essentially, the more you can do this, the closer you'll get to the correct area. So sometimes you'll be over, sometimes you'll be under. The more iterations you do, most of the time, the better the approximation will get.